All right, let's dive right in. Today, we are putting on our detective hats to crack a classic physics mystery I like to call the case of the connected blocks. It's a tale of pushing, pulling, and one single, beautiful law that runs the whole show. Let the investigation begin.
So here's the central puzzle we're up against. We've got three blocks all tied together in a line. There's a force yanking them in one direction and another, smaller force pulling them back the other way. The big questions are pretty simple. Who wins this tug of war? Which way do the blocks actually go? And most importantly, how fast do they speed up?
Okay, let's examine the scene. We've got three blocks with different masses, 1 kilogram, 4 kilograms, and 2 kilograms, all linked up like a little train. Now, they're sitting on a perfectly smooth surface. And trust me, that word smooth is our first major clue in this case. We absolutely cannot ignore it.
And now for the action. We have a pretty hefty 50 Newton force pulling the whole system over to the right. But fighting back, there's a 12 Newton force pulling to the left. It's a straight-up tug-of-war, and our job is to figure out who's gonna win.
So we've got our scene, we've got our competing forces. It's time to do what any good detective would do: lay out the facts of the case and treat this exactly like the puzzle it is. You know, in physics, every little detail is a piece of evidence. So let's start digging into the key clues we've gathered from the scene so far. Our first piece of evidence is the fact that these blocks are connected. This is awesome because it lets us treat them as one single system. They can't just go off and do their own thing. They're a team, and they have to move together. This is a game changer. We're not analyzing three different objects, just one big one.
Clue number 2, that smooth surface I mentioned. Now, this is a classic physics trick. It's basically code for you can totally ignore friction. There's no invisible force dragging on the blocks, trying to slow them down. This really simplifies our investigation. And our third and maybe most important clue is this idea of net force. Look, when you've got forces battling it out, the net force is just the final result, the overall winner. It's the force that's actually left over to cause a change in motion. It's the answer to who won the tug of war and by how much. Okay, with our clues gathered, we just need one more thing, a kind of master key to unlock this entire case, and that is the universal law that governs pretty much all motion in the universe. And of course, that law comes from the man himself, Sir Isaac Newton. His second law of motion is the fundamental principle we're going to use. It's an unbreakable rule that connects force, mass, and acceleration in this beautifully simple way. F equals ma. That's it. That little equation is our entire toolkit. Now, let's put it to work. All right, the investigation is over. It is time to crack this case wide open. We're going to take our evidence, we're going to apply that universal law, and we are going to solve this mystery. And here is our plan of attack. It's a super clear three-step process. First, we find the net force. Second, we calculate the total mass of our block team. And finally, we just plug those two numbers into Newton's law to find our answer. Simple. Okay, step 1, the net force. We've got 50 newtons pulling right and 12 newtons pulling left. Since they're fighting each other, they're working against each other. So to find out who wins, we just subtract the smaller force from the bigger one. And the result is 38 newtons. That's our net force. It means the 50 Newton force wins the tug of war, no problem, and the entire system feels a resulting pull of 38 newtons to the right. Boom, first part of the puzzle is solved. Now, for step 2, finding the total mass. Since we're treating the blocks as one big team, this is easy. We just add up their individual masses. So 1 plus 4 plus 2 gives us a total mass of 7 kilograms. So this single object that's being pulled by our 38 Newton net force has a mass of 7 kilograms. We now have the F times the M for our equation. We're ready. And now for the grand finale, applying the law. We want to find the acceleration, the A. All we have to do is a little bit of rearranging on that F equals ma equation, and we get this. Acceleration equals the net force divided by the total mass. So now we just plug in our evidence. Our net force is 38 newtons, our total mass is 7 kilograms. The acceleration is simply 38 divided by 7. We've gathered the clues, we've identified the law, we have done the math. So without further ado, it is time to reveal the final verdict in the case of the connected blocks. The acceleration of the entire system is 5.43 meters per second squared. And there it is.
Our investigation is a success. This number tells us everything. The blocks will move to the right, and they're going to speed up at this very precise rate.
But what does that number actually mean? Well, it means that for every single second that passes, the speed of our little block train increases by 5.43 meters per second. So it starts from a standstill and just gets faster and faster and faster.
So let's do a quick recap of our investigation. The case, a tug of war. Our key evidence, a net force of 38 newtons and a total mass of 7 kilograms. The law we used, the one and only F equals ma. And the final verdict, an acceleration of 5.43 meters per second squared. Case closed.
But you know how it goes. Just as one case closes, another one opens. We solved this mystery because the surface was smooth. But what if it wasn't? What if there was a hidden force, friction, fighting back against us the whole time? How would that change our verdict? That little idea is the key to so much more. But for now, it's just something to think about.